Grade 12 Trigonometry, Mathematics Paper 2. Let's have a look at some revision of the Trigonometry Grade 12. These questions are coming from GDE 2024 Prelim Paper 2. Right, when you're using a past examination paper, you have to be careful to not concentrate on the questions themselves, but instead get an understanding of the ideas that are being tested, the concepts that inform the answers to those questions. Because the questions may not be repeated, but what is definitely always there is that the ideas, the concepts are always tested. Now, question number one. What information do I need to be able to answer this question? If you see in a trigonometry question an angle that is added or subtracted from 180 degrees or the multiples of 180, if you multiply 180 by 2, for example, it will give you 360 degrees. So 180 degrees, 360 degrees, plus or minus theta. Then you must immediately know that in that particular question, you are going to be applying the reduction formulas. So that is one common item in trigonometry questions. We need to know how to apply reduction formulas. Then also tested in question 1 is 90 degrees. If we add 90 degrees to an acute angle that's 90 plus or minus theta, then this one we must immediately remember that this is co-functions. So in this particular question, we will need to apply co-functions. Then we have a negative angle there. We are given the sign of negative x. What do we know about negative angles? Negative angles are in the fourth quadrant. That is something to remember all the time. So we know that negative angles, negative acute angles, are in the fourth quadrant. Now in the fourth quadrant, cos is negative, cos is positive, but sine and tan are negative. So this one here will become a negative of sine x because in the fourth quadrant, sine is negative. If this was cos, the cos of negative x, the negative becomes positive because in the fourth quadrant, cos is positive. So in one question, I'm tested on reduction formula, on co-function, and also on negative angles. Then number 1.2, when you look at number 1.2, what needs to be done there, the whole 1.2, you are basically being requested to prove formulas. And when I do my studying, I don't look at this one particular formula only because I don't know which one they are going to bring if they choose to test this section. So go through all the formulas that are examinable. The cos of a plus b, the sine of a plus b, the sine of a minus b, and also double angle identities. How do you prove those formulas? It is necessary to just know the whole component because you don't know which one they are going to bring to you. Then number 1.2.2, if you see angles that are more than 90 degrees, that one must be a golden rule that you always remember. If angles are more than 90 degrees, then you must always remember to apply reduction formulas. Just like in 180 plus theta, 360 plus or minus theta, you must know that I must apply reduction formulas. It is a golden rule that in trigonometry, all angles must be acute angles. In all your calculations, make sure that angles are acute angles. If they are more than that, then you must reduce them using the reduction formulas. Then number 1.3, we have an identity. So for this one, we may need to remember fractions here. How do you simplify fractions? Addition and subtraction of normal fractions. We know that if you are adding fractions, for example, a over b plus c over d, then we multiply b times d to get one denominator, and then we cross multiply a b times c and a times d. So our answer is bc plus ad over bd. This is addition of fractions. Or we may say you make the denominators the same and then add or subtract the fractions. Then number 1.4, another very common question, general solutions. When you are solving a trigonometric equation, make sure that these angles are the same. You must have x throughout or 2x throughout. The size of the angle must be the same. So that allows me now, or that informs me on what to do with the cos of 2x. I must apply double angles to change it. Then also, the trigonometric expression you have in your equation must be the same. Make sure there is a cos, there is sine throughout, there is cos throughout, or there is tan throughout. Now, the formula for the double angle cos 2x, this is equal to cos squared x minus sine squared x. And this is also equal to 1 minus 2 times sine squared x. And this is also equal to 2 times cos squared x minus 1. So I've got three options for the cos of 2x. Which one am I going to take? If I know in my mind that when solving a trigonometric equation, make sure the trigonometric expression is the same. Have cos throughout or have sine throughout. So there are two conditions I've mentioned here. The angle must be the same and the trigonometric expression must be the same. That now allows me to quickly notice that I must replace cos 2x with the 2 cos squared x minus 1. If I do that, I satisfy the two conditions. The angle will become x only, and the trigonometric expression given will be the same. Then from there, I can solve my equation. Number 1.5. What ideas do we need to answer this type of questions? I am supposed to simplify and determine the value of sine 3 theta. Now, I need to find the value of sine 3 theta. Now, in my studies of trigonometry, I have learned the sine of a plus b or a minus b. I have also learned the double angles, which is the sine of 2a. I did not learn the sine of 3 theta, 4 theta, 5 theta, and carrying on. So now it means I must find a way of expressing this according to the formulas that I've been taught in class. And the formulas I've been taught in class is compound angles. So which means I can separate this into theta plus 2 theta. Now I have a compound angle which is going to mix up with a double angle. I have formulas for the double angle, I have formulas for the compound angle. From that position, I can be able to answer my question. So this is kind of a summary of the concepts that were tested in this particular examination. So let's have a look at how we can answer these questions one by one and make sure that we are clear on what to do should we meet this type of questions in an exam. Right, let's quickly put up our answers. Now that we know what to do, we know what ideas we need to be able to answer these questions. we can now simply go ahead and answer them. So this is my expression divided by the sine of 90 degrees plus x multiplied by tan x. So if you get an expression in which there is 180 plus theta, like we have already explained, the 180 falls away. Always, you remain with x only. That's reduction formula. Then if you see 90 degrees plus or minus theta, the 90 degrees falls away and the sine changes to cos and the cos changes to sine. That is reduction formulas. Now, the only catch that you must be careful with is with reduction formulas are the signs. Once the 180 falls away, the remaining expression is going to be positive or negative according to the cast rule. So in our case, this one is positive because it is squared. The squaring makes the negative a positive number. In the denominator, the negative sign of 90 plus x becomes a negative of cos x. Then I have tan. Tan is an identity. Each time we see tan, then we know that tan is equivalent to the sine of x divided by the cos of x. Once I do this, I now go on and divide common factors. Cos x divided by cos x, that will give me 1. The negative and the negative will make it positive. Then sine x divided by sine x, that will also give me 1. Once I divide all common factors, then the term that remains there is my answer for that question. So in this case, the answer is equal to the sine squared of x. Then I'm done answering question number 1.1. Just a reminder on the reduction formulas. If I get 180 plus or minus x, I must know as general knowledge that the 180 falls away. This is going to be plus or minus x. That is application of the reduction formulas. In an exam situation, if you can use your calculator, if it happens by any chance that you have forgotten maybe the reduction formulas and you are supposed to answer an exam, when you're in an exam it's about getting marks, use your calculator. So what you do, let's say I have the cos of 180 plus x and I can't remember whether it is positive or negative. Type this expression on the calculator. In place of x, you put an acute number, any number from 1 to less than 90. Let's say 1. Type on the calculator cos 180 plus 1. Then you press the equal sign. If the answer on the calculator is positive, this must give you a positive. If the answer on the calculator is negative, then it means this is a negative cos x. So if it happens that you have forgotten, you can use your calculator to check the sign. The sign must be correct because if it's not correct, the whole answer is also not correct. That is question number 1.1 answered. Number 1.2, we are given the formula for the expansion for the compound identity cos A minus B is equal to cos A cos B plus sin A sin B. And in this identity, we want to use it to determine the expansion for sin A plus B. We need to prove that. So this is what we have, the sine of A plus B. For us to be able to do this, we use cofunctions. Go back to the formulas for cofunctions and the particular formula for cofunctions that we need in this case is the one for cos, the cos of 90 degrees minus theta. The cos of 90 degrees minus theta is equal to the sine of theta. This is the formula that we apply. So in this formula, in place of theta, we substitute theta with a plus b, such that cos 90 minus theta becomes cos 90 minus a plus b, which is equal to sine theta, and the sine of theta becomes the sine of a plus b. That is my co-function. So that is what we do in this particular question. Then, so let's quickly do that and see how it will be like. So the sine of a plus b is equivalent to cos of 90 degrees minus theta. In place of theta, we now have a plus b. Then we need to simplify this expression by applying the compound angle identity. So simplified, this is equal to the cos of 90 degrees minus a minus b in brackets. Then to work out your answer going forward from here, applying the expansion for the compound angle identity for cos, we're going to take 90 minus a. We're going to take 90 degrees minus a. In the formula, this part, the 90 degrees minus a, that's where you put your angle a. Then obviously the last one will be your angle b. So this is cos of a minus b. That's cos a minus b. A is 90 minus a. Then in expanded form, the cos of a minus b is equal to cos a cos b plus the sine of a sine b. That is your formula. Now let's substitute into this formula to complete our proof for the sine of a plus b. So we're going to say this is equal to putting 90 minus a in place of a in this expression here. We're going to get cos a, which is the cos of 90 minus a. Then cos b, that's cos b, plus the sine of a, which is the sine of 90 minus a. Then sine b. From here, we apply co-functions again. The cos of 90 minus a is equal to sine a. So this is sine a multiplied by cos b plus the cos of a multiplied by the sine of b. This is our answer. The sine of a plus b is equal to sine a cos b plus cos a sine b. So what we did here is to simply apply co-functions. In that way, we have answered number 1.2.1. Right, question number 1.2.2. Now, most times, not all the times, but most of the time, if you are requested to prove a formula, the next question will ask you something on application of the same formula that we're proving in the previous calculations. So in number 1.2.1, we were proving the sine of a plus b given the cos of a minus b. Then in the next question, we have an expression that needs application of the same compound identities that we were working with in question number 2, 1.2.1. That is something to look forward to. So let's have a look at what to do here. Now, these big angles, you must make sure in your expression all angles are acute angles. You must not have angles that are more than 90 degrees. If angles are more than 90 degrees, then we must apply reduction formulas to reduce them. The 420 is the same as the cos of 360 degrees plus 60. We simply have to subtract 60 from 420. Then the next angle is 15 degrees. That's fine. It is already an acute angle. And the next one, the sine of 300 degrees. We know that this one is equal to 360 degrees minus 60. That's how we can get 300. Then the last one, the cos of 105 degrees, we can express this as the cos of 180 minus 75 degrees. So this is application of reduction formulas. This sentence that I just wrote now is not necessary to write in an exam, but I'm just writing it to show you where my numbers are coming from. So the first angle is equal to cos of 60 degrees. Then I have the cos of 15 degrees. And the next one, the sine of 360 minus 60, that one changes into negative because it is in the fourth quadrant. So that is the negative sine 16. Now I am applying reduction formulas. There is nothing much so far that I'm doing except application of the reduction formulas. So I have a negative of the sine of 60 degrees. Then from there, the last one, which is the cos of 180 minus 75. That one is the same as a negative of the cos of 75 degrees. That is my expression. So now I have a very nice expression here. The cos of 60 degrees, the cos of 15 degrees, then these two negatives can make it a positive, that is plus the sine of 60 degrees, then this one is the cos of 75 degrees. Now, you have done some studying. So in your thoughts, you should know we are applying compound angle identities here. If you see an expression where there is a cos and then there is another cos, and the next one, obviously, for compound angle identities, we must have sine and another sine. So if you look at my angles, this one is 60, then I also have got 60 here. If I make that one A, then I can say that I have got cos A in the first expression. Then if I make this one B, it means I've got cos B plus the sine of A. Now, for my formula to work, I must have cos A, cos B, sine B, which means this angle here must be 15 degrees. Now, how do I change cos 75 to sine 15 degrees? For that, I need cofunctions. I know that the cos of 75 from cofunctions, the cos of 75 degrees is the same as the cos of 90 degrees minus 15. The cos of 90 degrees minus 15 is equivalent to the sine of 15 degrees. So which means in place of 75, I can put sine 15 degrees in place of cos 75 degrees. That will now allow me to apply the compound angle identity. Once I do that, then it becomes easier to determine the answer that is required for this particular question. So I have the cos of 60 degrees multiplied by the cos of 15 degrees plus the sine of 60 degrees multiplied by the sine of 15 degrees. So if you take this as cos A cos B plus sine A sine B, then you will see that it is the same as the cos of 60 degrees minus 15 degrees. Then 60 minus 15 is equal to 45. So this is the same as the cos of 45 degrees. 45 degrees is a special angle, so the answer to this question is root 2 divided by 2, or we can express it as 1 over the square root of 2 from the special angles triangle. That is the question number 1.2.2 answered. So quickly, what do we learn from this particular question, or what are we reminded of when you are in an exam situation? I must be able to remember that when I'm working with big angles, always make sure that the angles are changed to acute angles. Then I must also know very well how to identify the compound angles in a given expression. The compound angle for cos is always cos, cos, sine, sine. Then the compound, this one you know, this is going to give you the cos of A plus B. It's always cos, cos followed by sine, sine. If I get expressions in that way, then I know I am working with compound angle for cos. The compound angle for sine is always cos, sine, then sine, cos. They are alternating. Then I know that the formula needed here is the sine of A plus or minus B. That's how I identify the compound angle identities in an expression. So once you reduce your angles to acute angles, you can see how the angles are appearing in positions of A and B, and then you apply your formula, and your question is right. Question number 1.3.1. We are given an identity that we need to prove. Very nice and cute. Also, there can be no reason to get diarrhea from these kind of questions. So tan squared x uh, divided by a tan squared x factor of 1 over tan squared x minus 1. We want to prove this identity. It is equal to the cos of 2x divided by cos squared x. Now, you always have an option. Either you work out the right hand side and make sure that it is equal to the left hand side, or you work out the left hand side and make sure that it's equal to the right hand side. In some cases, you may need to work out both and make sure that you produce the same answer at the end. So I'm working out the left hand side of my expression, working out the left hand side. So the first thing that I notice in this expression is that I have brackets. And we know that brackets can be removed by multiplication. So if I multiply here, multiply, and also multiply there, that will definitely remove the brackets. And after removing the brackets, I can go ahead and simplify my expression. So tan squared x multiplied, this one is over 1. So if I multiply, the tan and the tan are going to divide each other. You get 1 minus, then tan squared x times negative 1 is going to give us tan squared x. So our answer to this question is 1 minus tan squared x after removing the brackets. Then from there, what do we know about tan? Tan is a very nice guy. If you see tan, it means sine over cos. So tan squared x is the same as sine squared x divided by cos squared x. Now, we now have fractions. Nice and cute. What do you do when you are adding fractions? You make sure that the denominators are the same. So the bottom, the first fraction 1 over 1, I'm going to multiply that one by cos squared x and also multiply by the top one by cos squared x. That will allow me to add the fractions because when the denominators are the same, we can add the numerators. My expression now becomes cos squared x minus sine squared x divided by one denominator, which is cos squared x. Then the top one, cos squared x minus sine squared x. You have done your formulas very well. You should be able to notice that it is equal to the cos of 2x. So this is cos 2x divided by cos squared x. My identity has been proved for 3 marks. What do we learn from this question? Number 1 is brackets. We must know how to remove brackets and simplify an expression. And apart from knowing how to remove brackets and simplify an expression, we also must be able to add or subtract fractions. Alternatively, someone can choose, we can also say that the expression, the left-hand side, tan squared x, then the two numbers that are in brackets, we can add them. So that will be 1 over tan squared x minus 1. This 1, we make the denominators the same by multiplying the top one and the bottom one by tan squared x. So it will be tan squared x divided by tan squared x. Then we simplify our expression going forward. So now we have tan squared x factor of 1 minus tan squared x divided by one denominator. When the denominators are the same, you can add the numerators. So this will divide tan squared and that tan squared, giving you 1 minus tan squared x. Then we change the tan squared into sine squared x divided by cos squared x. Now, after doing that, we make the denominators the same by multiplying 1 over 1 by cos squared x. So it will give us exactly the same answer, cos squared x minus sine squared x divided by cos squared x. Then we use our double angle identities to complete our answer. The numerator is equal to cos 2x. The denominator is cos squared x. This is the expression given on the right-hand side. So in doing that, I have proved the identity given in 1.3.1. The number 1.2.2, number 1.3.2. This is a very common question. Each time we get identities, they always love us enough to ask this question. For which values of x is the identity undefined? Undefined happens when the denominator is equal to 0. To find the values of x for which the given identity is undefined, simply equate the denominator to 0 and solve for x. So here cos squared x is equal to 0. And then from there, this one it's a simple one, you can work it out with a calculator and it's only 1 mark. So in this case, x is equal to 90 degrees. Normally, we would express our answer as a general solution, but here they've specified the range of answers they want. They want the answers from 0 to 108 degrees. So the idea in 1.3.2 is that the values of x for which an identity can be undefined, you always equate the denominator to 0 and solve the equation for x. That will give you the required answers. So you've answered number 1.3.1, proving an identity and determining the values of x for which the identity is undefined. Number 1.4, general solutions. This is another name that gives people unnecessary stomach sounds. General solutions. We want to determine the general solutions. Cos 2x is equal to cos x for 6 marks. Imagine, these are 6 free marks that you must make sure you don't miss. Now, how do we solve a problem like this? Some ideas that we must keep in mind. These expressions must be the same. So make sure that your equation is exactly the same trigonometric expressions. There is a cos throughout the equation. There is a sine throughout the equation. That is one of the things. So in this case, we are fine because we have got cos and we also have got cos. You must have the same trigonometric expression in your equation. Another consideration to make is that the size of the angle given must be the same. So these two angles here, they must be the same. And I can see that in my expression, they are not the same. One is a 2x, the other one is x, which means I must find a way to make sure that these angles are the same. At the same time, making sure that I have got the same trigonometric expression in the equation. That brings us to double angle identities. We know that the cos of 2x has got 3 options. So it is equal to cos squared x minus sine squared x. It is also equal to 1 minus 2 times sine squared x. It is also equal to 2 times cos squared x minus 1. These are my 3 options I have for cos 2x. Which one am I going to take? I'm not going to use the prophetic ministry to determine that. I want my equation to have the same trigonometric expression. Given that I have cos on the left, it means out of these 1, 2, 3 options, I'm going to choose one that is cos only. So therefore, cos 2x is going to be substituted with 2 times cos squared x minus 1. So this is equal to the cos of x. Now I have made sure that my equation has got the same angle, which is x, and the trigonometric expression given there is also the same. From here, if there is a square, it should remind you quadratic equations from paper 1. So the golden rule for a quadratic equation, we have to simplify our equation until it is in standard form. So standard form means we equate the entire equation to 0. After equating to 0, then from there we can use a factorization, quadratic formula, or completing the square to solve the equation. So this one here can be factorized into two brackets. So I'm going to factorize it into 2 multiplied by cos x plus 1 in one set of brackets, factor of cos of x minus 1. This is equal to 0. Then I complete my equation. 2 times cos x plus 1 is equal to 0, or the cos of x minus 1 is equal to 0. So from this bracket, we can make cos x the subject. Cos x is equal to minus 1 over 2. And then in the next one, the cos of x is equal to positive 1. That is my equation. Then I must solve this equation separately to determine the two values for x that we need. Now, in this first equation, determine the reference angle here. The reference angle, you use a calculator to find this. And we must emphasize that this is not the answer. It is the angle that we are going to use to determine the answer. And when I put this in the calculator, I don't put the negative sign. Leave the negative sign out and put half only. So this will give you your reference angle. In our case, the angle is equal to 60 degrees. You can use a calculator for that, or you can even remember that half comes from special angles. So the cos of 60 is equal to 1 over 2. Now, after that, we look at two things. Please, I hope you remember this. Now, look at this value. Remember that negative sign that we did not put in the calculator? That negative sign tells us the quadrants in which the solutions for this equation are. We must go to the quadrants where cos is negative, because cos x is equal to negative 1 over 2. And we know that cos is negative in quadrant 2. The measurement of the angle in quadrant 2 is 180 minus theta. Cos is also negative in the third quadrant. The measurement of the angle in the third quadrant is 180 plus theta. These two are the solutions for that equation. In place of theta, you put your reference angle. So I can say x is equal to 180 minus theta, which will now be 180 minus 16. So if we say 180 minus 16, that gives us 120 degrees. Then we add k times 360 to make it a general solution. Then my next solution is going to be from the third quadrant, 180 plus theta. 180 plus theta is going to be 180 plus 60. That will give me 240 degrees. Then we can add this to k times 360 degrees. I have solved the first equation to get two general solutions from it. Then the next equation, if your cos x is equal to 0 or 1, those are called quadrant angles. So we can find the answer from the calculator straight away for this one. X is equal to 0 degrees. Then we add k times 360 degrees. In each case, k is an integer. Please don't forget to write that. In each case, k is an integer. This is our solution. We have solved the equation and our answers are now done. That's general solutions. I hope you learned something from it. When you're working out the quadratic part, this part here, where you are supposed to solve the quadratic expression. So let me just quickly write it here. My equation is 2 times cos squared x minus cos x minus 1 is equal to 0. You are allowed to use k or to use any variable to make your expression simpler. So I can say let k be equal to cos x. Then it means this equation can be expressed in terms of k. It will now be 2k squared minus k minus 1 is equal to 0. Then we apply the quadratic formula to solve for k, or we use factorization that we have used in this question to find the value for k. Then after determining the value for k, you can revert back to cos x and continue to solve the equation. You can also do that. And remember, when I solved for cos x is equal to negative 1 over 2, when you determine the reference angle, you don't put the negative, you put the positive 1 over 2 to get your reference angle. Then the negative sign is there to tell you the quadrant from which you must read your answers. That is number 1.4, general solutions solved. Right, question 1.5. Now in question 1.5, we are told that the sine of theta is equal to 1 over 2. And then with that information, we need to be able to find the value of the sine of 3 theta. And this is worth 7 marks. It was worth 7 marks in this particular examination. So basically, now this one is 7 marks. I'm not so sure why the examiners thought this may be 7 marks, because the calculation is very straightforward here. Now, we know that from special angles, when working with special angles, if you go back to special angles, we know that given 30 degrees and 60 degrees, then we can find the values of special angles. The sine of 30 degrees from the ideas of special angles is equal to 1 over 2. So which means if they tell us that the sine of theta is equal to 1 over 2, then we can safely say that theta is equal to 30 degrees from special angles and without using a calculator. Then if theta is equal to 30 degrees, it therefore follows that the sine of 3 theta is going to equal to the sine of 3 times 30, which will be simplified to give us 90 degrees. And once again, 90 degrees is also part of the special angles. We can find the value of that one without a calculator. The sine of 90 degrees is equal to 1. And that definitely answers the question. That's why I'm saying I'm not so sure why it was given 7 marks, but otherwise it's a straightforward calculation. The answer to this question is equal to 1. I have answered that question. So what do we learn? What we may want to also emphasize using the same question? Let's say for a moment that the sine of theta is not equal to 1, but instead it is equal to something else that we are not able to determine without a calculator. Then we probably may want to remind each other that the sine of 3 theta, our formulas talk about 2 theta, which is a double angle. But once we say 3 theta, 4 theta, 5 theta, then it means we must find a way to separate the given angle so that we may be able to apply the formulas that we have. So 3 theta can be written as theta plus 2 theta. Now, after doing that, we now can see that we have a compound angle identity for sine that we need to expand. So sine A plus B is equal to sine A cos B, which means the sine of theta plus 2 theta is equal to sine theta cos 2 theta plus the cos of theta multiplied by the sine of 2 theta. We have now removed 3 theta. We now have something that we can simplify, use the formulas that we know. So given that in the beginning we are given the value of sine theta, which is equal to 1 over 2, it informs us that we need to simplify this expression and make sure that we have got sine theta throughout so that we can substitute at the end of the day. So that means going forward, we can have sine theta, the cos of 2 theta, that one has to be substituted by 1 minus the sine squared minus 2 times the sine squared of theta from the formulas for double angle identities. Then going forward, this one is the cos of theta, then multiplied by the sine of 2 theta, which you can write as 2 times the sine of theta times the cos of theta, also from double angle identities. Then moving forward, removing these brackets here is going to give us the sine of theta multiplied by 2 times the sine cubed of theta. Then the next one, if you multiply cos theta times cos theta, that will give us 2 cos squared theta. So we have got 2 times cos squared theta, then multiplied by the sine of theta. Now in this expression, we know that cos squared theta can be simplified or can be substituted. So if you take out this part of your expression and replace it with 1 minus sine squared theta, we know that identity from grade 11. Then your expression can be simplified. Sine theta is equal to 1 over 2. So this one will become 1 over 2. This one will become 1 over 2 to the power of 3. This one will become 1 over 2. This one will become 1 over 2. Then you simplify and complete your answer. That is number 1.5 for 7 marks. Just to explain how we can use compound angles to simplify this type of angles. Otherwise, you can use this first calculation here if you have special angles, and that will reduce to a very large extent the working out that you are supposed to have. And then your answer is complete. We have now answered the whole. Right, a quick summary of what we have discussed in this question that are going to be needed. Number 1, make it a priority that you for sure know how to do reduction formulas. If an angle is added or subtracted from 180, then it is a reduction formula. It's 180 degrees and the multiples of 180. So if you multiply 180 plus or minus theta, it will become 360. Or if you multiply 180 by 4, for example, then we may end up having bigger angles like 720 and so on. Then you know this is reduction formulas. When you apply your reduction formulas, the 180 falls away. So the 180 falls away, and this will give you plus or minus theta only. The 360 falls away. This will equal to plus or minus theta without the 360. The only one challenge that you must make sure you observe is that the sign of the result may be a positive or a negative, depending on the cast rule. If it happens by any chance that you have forgotten, we said you can test with a calculator. If I want to find, for example, the cos of 180 plus theta, let's say I can't remember my angles by any chance, then I can use a calculator, put any number which is acute in place of theta. Let's say 1. Then this will become the cos of 180 plus 1. You get your calculator, you work out cos of 180 degrees plus 1, you press the equal sign. If the answer there is negative, then it means your expression must have a negative answer. That is reduction formulas. The reduction formulas, they come with cofunctions. I must remember that 90 degrees plus or minus theta, two things happen when I'm working with a cofunction. The 90 degrees falls away, then sine changes to cos, and cos changes to sine. And when I do that, there is one that learners forget a lot. Just to remind you, it is the cos of 90 degrees plus theta. The cos of 90 degrees plus theta, yes, the 90 degrees falls away and the cos changes to sine. But this particular one changes into negative sine theta, because sine 90 plus theta is an angle in the second quadrant where cos is negative. With the reduction formulas, we need to remind you that if an expression is squared, let's say I get the cos squared of 180 plus theta, this is supposed to be negative cos theta because it is in the third quadrant. But because of the square squares the negative back to positive. So the answer will be a positive cos theta. Then number 1.2.1, we have reminded each other that you can prove this identity using the cofunctions. In number 1.2.2, we apply the reduction formulas as well. If you see big angles like these ones, reduce them using reduction formulas to acute angles. Then number 1.3, fractions. Fractions. To add fractions, we make the denominators the same. Then number 1.3.2, undefined. This word will definitely appear a lot. If something is undefined in mathematical fractions, then it means the denominator must equal to 0. Equate the denominator to 0 and solve for x. That will make sure that you've got the values that can make the identity undefined. Then number 1.4, we spoke about general solutions. Two ideas there. Number 1, you must make sure that the angle size is the same. Cos 2x and cos x. There is x and there is 2x. That's a problem. That means we must substitute 2x, cos 2x, using the double angle identity. But we know that the cos of 2x has got three equivalences. There are three forms in which you can express the identity: cos squared x minus the sine squared of x, and it is also equal to 2 times cos squared x minus 1, and it is also equal to 1 minus 2 times sine squared x. These are my three formulas for cos 2x. Which one am I going to choose? I don't want to just grab, and all of them are valid, but some may make your expression longer, and that will cause you to not finish the exam. So I need one that can help me faster. To decide on that, I must make sure that a trigonometric equation must have the same trigonometric expression throughout. Given that I have cos already in the equation, it makes sense to choose the second one. Then I can simplify to standard form and solve the equation. Then number 1.5, we said this type of angles where theta is multiplied by 3, by 4, by 5, we may have to decompose them and separate them and express them as compound angle identities. Then we can apply the compound angle identities to solve the problem. That's what we have discussed generally in this question. This is from GDE Prelim paper 2 for 2024, Trigonometry Mathematics paper 2, grade 12.